These are algebra notes for section 3-6, arithmetic sequences. So an arithmetic sequence is an ordered list of numbers that forms a pattern with a common difference. Later in the year, we're going to learn about geometric sequences, and those will have a common ratio. When we have a common difference, we are using addition or subtraction to get to the next term. So in this sequence, or this list, we've got 2, 5, 8, 11, 14, and a long time ago you could have said, okay, we're going to add 3 every time. And that makes it an arithmetic sequence because we add the same thing each time. So in these first examples, we just need to determine if the sequence is arithmetic, so plus or minus. Geometric uses multiplication. When the number gets smaller, it looks and feels like division, but it's actually multiplication, and then neither. So let's take a look at the first one. 3, then 4.5, then 6, then 7.5, then 9. So each time to go from one to the next, I'm adding 1.5. So my common difference is 1.5. And I can say that my first term is 3. And then the next 3 terms in the sequence come from taking 9 and then adding 1.5. So that would be 10.5. And then add 1.5 again. That would give me 12. And then 13.5. The next one starts at 4. Then goes to -4, then to -20, -12, then -20. And to go from one to the next, we are subtracting 8. So that is our common difference. The first term is just the first number in the list. And then the next 3 terms, if we continued on, we'd have -28. Subtract 8 more, so -36. And then -44. Now, if we graph these, we're going to look at the y value of these points. So we've got a y value of 12. Then, let's see. The first term would be 12. So 12, then 8. Then 4, then 0. So to go from one to the next, each time we're subtracting 4. And the next 3 terms would be -4, then -8, then -12. Okay, when we're studying these, we have 2 types of formulas. The first one's called an explicit formula, and an explicit formula is used to find any term. And there's some important parts of it. So a sub n is just like how we start that equation. And then a sub 1 is always the first term. N is the number of the term you're solving for, and D is that common difference. And then there's another type of formula called a recursive formula, and it uses it looks different, and it's used to find the next term. So we use some different notation. So a sub n tells us that it's the whatever term 1 less than it. N is the term you're solving for. D is the common difference. So we're going to take a look at these next problems. And I can see from 15 to 13, I'm subtracting 2, 13 to 11, subtracting 2, subtracting 2. So the common difference is minus 2, and the first term is 15. And then we're going to use the explicit formula. We're going to write one and find the 25th term. And when we do this, it's going to feel like a slope-intercept equation. And we can see that this picture on number 3 up top, it has a linear pattern. So let's see what we get when we use this formula. So the explicit formula is a sub n equals a sub 1. So that's my first term plus the common difference times n minus 1. Okay, so a sub n in the front just stays a sub n. And a1 is that first term. So we're going to start at 15. And the common difference is negative 2. So instead of saying plus negative 2, I'm just going to put minus 2 times n minus 1. So that's 15 minus 2n, and negative 2 times negative 1 is plus 2. So we're going to combine our like terms. So a sub n equals 15 plus 2. That's going to be negative 2n plus 17. You could also do 17 minus 2n. So if you check the, let's say, the second term in the sequence, so we would put a 2 for the n to just say, hey, I'm going to tell you what the second term in the sequence is. So that's a negative 2 times positive 2, because I put that where the n is, plus 17. So negative 4 plus 17 makes 13. So that was me saying, hey, the second term is 13, and that's what it is in the problem. So now we're going to check the 25th term. So we're going to use this formula we wrote and say a of 25. So the 25th term would be negative 2 times 25 plus 17. So negative 50 plus 17, a of 25 would equal negative 33. We're going to do that same process on the next formula, on the next group. So to go from 77 to 64, 64 to 51, each time we're subtracting 13. So that becomes my common difference. And the first term, that's my a sub 1, not 15, what am I thinking? That was my last time. My first term in this case is 77. So when I use that explicit formula, a sub n equals a sub 1 plus the difference times n minus 1. So a sub n equals a sub 1 plus the difference here is negative 13. So I'm going to put, instead of plus negative 13, I'm putting minus 13 times n minus 1. And I should have made a1. Let's fix that. What was I thinking? The first term was 77. Okay, so that's 77 minus 13n. Negative 13 minus 1 would be plus 13. And when we combine our like terms, we can say a sub n would be negative 13n. And when we combine our 77 and 13, that will be plus 90. Okay, we could always check. So I could check with the, let's say we're going to check with the fourth term in my given sequence. A of 4 would be the first term, 77, Nope, I'm using the wrong thing. Negative 13 times 4 plus 90. When we simplify that, negative 13 times 4 would be negative 52 plus 90. So that would be 38, and that is our fourth term. So that tells me I did it right. Now, when I want to find the 11th term, I'm going to do a of 11 equals negative 13 times 11 plus 90. Let's see, 13 times 11. So 143, negative 143 plus 90. And when I subtract those numbers, I'm getting a of 11 would equal negative 53. Our last example says an online store charges $5 to ship 1 box, $10 to ship 2 boxes. So I can tell 1 box is 5, 2 boxes is 10, 3 boxes would be, and we can show it this way. I can make a table. Number of boxes, and then we could show dollars to ship. 1 box, $5. 2 box, $10. We can assume that this pattern is going to keep going. 3 would be 15, 4 would be 20, and so on and so on. So our formula, a sub n equals a sub 1 plus the difference times n minus 1. So the first amount is 5, and the difference is 5 times n minus 1. So when we do this, 5 plus 5n minus 5. So the 5 and the minus 5 cancel out. So a sub n is just 5n. And when we want to find how much it would cost to do 11 boxes, we'll just use our formula. We just wrote a sub n is 5n. So that's a 11 equals 5 times 11, 55. So $55 to ship 11 boxes.